Alright, so today we're going to be talking about using the ADT either to build out our own form validation. And if you're new to the channel, the last 3 videos that I covered were on algebraic data types and type classes. And I broke down type classes into 2 different videos, so be sure you go back and give those a watch before you just dive into this video if you're new to the concept of functional programming, because that's really going to tee you up for everything that we're going to be covering in this series. So without further ado, today's topic is going to be about using either, like I mentioned, and we're going to be building out form validation, our own form validation, without pulling in a third-party service to do so. And the point of using this data type, it'll put all of our errors in a single place so that it's easier to deal with, but it will also put any success values as well in a single place. Basically, the idea here is, if you recall in one of my previous videos, I said that the algebraic data type either can have a left or a right value. And convention dictates that errors go in the left and success values go in the right. In addition to that, we spoke about applicatives in the very last video for type classes. And we said that applicatives give us the ability to lift multiple operations up and run them concurrently or in parallel. And you can kind of think of promise.all, the way that that works, where you can store, let's say, 3 or 4 different network requests in a single collection and use promise.all to run through all of them, wait for them to all be finished, and then you either get a success value or something will error and it'll drop down into the catch block. So using either as our data structure, we know that what we want to do is build out this functionality that can either house errors that we can gracefully handle or report if needed, or it's going to house a successful validated form with the values that we expect, which need to be shipped off to the back end somewheres. So using both of those together, we're creating an abstraction for dynamically supplying multiple conditions to a form. Conditions being like predicates, like does the value provided contain an uppercase letter? Does it contain a number? Is it at least 6 characters long, etc.? And the whole purpose here is to kind of show you how we can stream these different conditions together to build out this validation logic in a very robust and reliable way, such that it's easy to maintain should you ever need to come and refactor or add more things to this validation pipeline. And just to over communicate the value add here, what we're trying to do is filter out or reshape supplied data into the desired output or shape of the data that we need it to be in, so that it integrates with the rest of our application and data model. Okay, so to kick things off, we're going to look at the JSX of this form right here that we're building. On the left side you have your form, and on the right side this is just the validation errors. This is for demo purposes to show you how things error out and what they look like. But back into the code, we'll just run through this briefly. So obviously we have this in the grid container, and then you have 2 fields. You have your email and then you have your password, and both of them look identical. So in the on change, we want to set the email, and we're going to wrap the value in an option. But if the value is an empty string, then we're just going to set it to none. And then in the value, we're going to take that email option, this is stored in state, and you can see that it's an option of string, meaning it can either be a none or a sum. This is kind of similar to the either data structure in that it can only have 2 different nested types. So what O to undefined will do is unwrap that value and give you the actual thing inside of the sum, but if it's a none, it'll just default to undefined. Alright, so same exact thing is happening with the password right here. And then, as you would imagine, whenever we click submit, we want to run our form validation. And then on the right hand side, this is what we're using to show the errors. So if up at the top we have an option that's wrapping an array of strings, meaning that we either have them or we don't. And if it's none, then that means that we're in the success case, kind of, in the sense that no errors have been reported. So this is what that looks like. And then whenever we have errors, it's going to turn red. So if I go ahead and just fail this real quick, you can ignore this message at the bottom, and I click submit. Well, then you see our errors over here. Let me slide this over so you can see it a little bit more. There we go. So I'll refresh the page. All right, so we're green. And then if we put something in here and submit, it's bad. Okay, moving on to the errors portion. Up at the top, we have our label, and the condition for showing green or red is going to be based off of whether or not we have any validation errors at the moment. If we don't, then this is going to be true, meaning that there aren't any, and we'll go ahead and show our green. Otherwise, we're going to turn the color to red. And then right here, we're using the pre tag to go ahead and do this, this formatting of our object where we stringify it and we indent by 2. So what this looks like in practice, if I come in here and I actually fail this, then you can go ahead and see. So this is the formatted output, and you can see that the colors are red to correspond with the error case. If we refresh, we're back to having no errors. All right, so now what I want to do is jump up into this handle form validation. But before I do, let's just take a look at the state up at the top. So I'll actually make this a little bit bigger. Okay, so we have an email option, a password option, and then these validation errors. And all of these you can see are housed in this other ADT that we've also covered called option, where you can have a some or a none. And that's exactly what it looks like right there. Okay, so what we're going to do, like I said, is we're going to take either, this is our imports, by the way, E for either, O for option, A for array, and app for apply. Apply is where we're going to get our applicative instance from. And then, as you know, piping is for composition of functions from left to right. And we have our different validations or our conditions that we're going to supply our form validation. And we'll go into those in just a second. But coming back down here, so we build up this applicative validation where we take this helper function and we say, this is how we want to collect the errors. Because we know how the errors are going to be, they're going to be an array of strings. Then we use this array and this helper get monoid, which basically just tells us how to combine things. And we pass in this generic value, or this, it's not generic, this explicit value of string that informs this function of what it's combining. So if this was numbers, the way of it combining might be slightly different than if it's combining strings. So given that, we take this function and then we pass it into this sequenced validation, is what I've called it. So using the applicative, or sorry, the apply module, we pull off this sequence T. And the sequence T is a lot like the promise.all interface. And it's going to make more sense in just a second. But what we do is we take this, which tells us how to combine our errors or give us back our success values, and we pass that into this. And now this function is ready to take arguments. So what we do is this validate input field is going to take an empty error message and a string, or an option of a string. And it's going to take these 4 different conditions, these validation conditions, to run on the string that was supplied. So now's the time where we're going to stop and go and look at these functions and how they're defined. So we'll come over here to non-empty. And you can see in the comment it says that it returns a left value if it's empty and a right value if it wasn't empty. So if you didn't give me anything at all, then I'm going to report back this supplied error in the left track. And this is, we're putting it back into an array so that it can accumulate the way that we want it to. Otherwise, we're just going to give back the value. The next condition is the min length. And this one, we're not supplying an error message because we've hard-coded what we want our error message to be. And this is just going to check that the value supplied is at least of 6 characters long. If it is, it's just going to pass back the value, and we repackage it in a write so that we can continue building off of this this interface while we're still nested within this algebraic data type. Otherwise, if it wasn't at least 6 characters long, then we're going to package the error message like we did up above in an array. Okay, and these other two are basically the same, or they function the same, in the sense that we take the string that was supplied, which again is wrapped in an option, and then we pass this predicate where we're doing this regex check, and we're just trying to make sure that the supplied value contains at least one number. And if it does, then go ahead and give us that back. If not, let's give back this error message, which is also wrapped up in an array. So just a quick note again to make sure that this is clear. All of these error messages are in an array so that it meets this criteria right here, which is saying how we combine the errors that are reported. Okay, so we just went through what each of these are, and now let's just take a look at this comment which says run all of these validation checks in parallel. And this is what I mean by it's very similar to promise.all. It's going to run all of these in parallel, and it's going to report back any of the error messages that occurred. So what that means is that if any of them fail, then you're not going to get back a successful value. You're going to get back an error that contains which things failed. All right, so otherwise, this e.map, what it will do is actually operate on the right value. So only if all of these have passed from 28 to 31, if all of those have passed, we'll be in this success case right here. And if I remove this and just do this and hover over it, you can see the success track contains 4 values. They're all the same value because we piped the same string that was supplied to this overall function into each of these conditional checks or each of these predicates. So what this has given us back, just as promise.all would give you if 4 different network requests resolved, it would give you this tuple, if you will, of 4 values. In this case, they're all the same. So what we're doing is destructuring right here and pulling out the first one and just giving that back. And again, this will only run if all of these were true. So we take this validated input and what we'll do is pass it over here. So we're reusing it. We abstracted this behavior into another function that can be passed along any way that we'd like. So now what we do is we take the same sequence validation up there that we described, which is how we want to run things concurrently. And it also has how you want to build up error messages. And we take that down here and we want to validate input field for our email option, and we want to validate the input field for a password. And this error right here is that custom error that's going to be given back if the first thing failed, this right here. So this generic error message is what we're passing through right here. Again, the other ones don't have it because we have hard-coded error messages supplied for those. We do it generic here so that we can say specifically what field is missing. Okay, so we take both of these, and now if we look at it right here, you can see what this looks like under the hood. We either have a collection of errors that have been accumulated across the different fields, or we have a tuple of two different strings this time. And they're different because of, if you look at the sequence validation here, we have different values that are being piped in, the email option and the password option. So whenever we fold that out right here, very conveniently, we have all of our errors in one spot. No matter how many input fields we put in, all of them would be consolidated in this one area. This makes maintaining and refactoring a breeze. It makes it so much easier to come in and adjust this logic if it needs to be. So if things don't fail, now we're in the success case where we have the email and the password, and it's definitely safe at this point in time to do whatever operations we need. So here we set the validation errors to none, and we go ahead and log this form. Now I want to go ahead and show you what this looks like in practice. So let's just pull this up side by side. Cool. So you can see here we're saying it cannot be empty, and we need a min length of 6 is what we said in the function, which is just arbitrary. It could be whatever, right? It must contain at least one capital letter, and it must have at least one number. So if we come in here and we say hi at example.com, what do we get back? Well, it's not empty, so we pass to the next few checks, and we see that it needs to contain at least one capital letter, and it needs at least one number. Because you can see we've supplied more than 6 characters, and it's not empty, so 2 conditions are met, which just leaves us with line 30 and 31, where it doesn't have a capital letter, and it needs a number. So let's go ahead and add that. Okay, now we're just missing a number. Let's say 6. Okay, cool. Now what's left is just the password. So we haven't supplied anything in the password field, so we'll go ahead and do that now. And we'll see what's left. And we didn't supply a capital letter or a number. So if we do that now, let's try that. Boom, where there are no more errors. And you can look down here at what was logged in the console and see that. Let me make this much bigger. I think that's good. Validated form, here's our values. So now theoretically we can do whatever we want. We can send this off to a network request, or we could just package this up and send it to another part of our application, store it in global state, you name it. But at this point we have very clear intentions of what this part of the program is supposed to be doing, how it's handling any errors if something goes wrong, and what it's doing with the successful values. Okay, so running things concurrently or in parallel like we just did is cool, but there's also times where you need to kind of sequence things in a way that are more procedural. So you could think of 2 different forms where this form needs to be completed before this form can be completed. You could think of this like maybe a checkout page that requires your payment information before you can put your address, like where things are being shipped. So what we could do is use a different syntax altogether and a different a type class or monadic interface to facilitate this sort of like staggered set of instructions. So again, if we leave them both blank, you can see that it says email cannot be empty and password cannot be empty because it's ran our validation on both fields at the same time. But if we want to implement a fail-fast solution, meaning that we don't want to accumulate all of the errors from multiple input fields, we just want to fail right whenever the first one doesn't pass. So what we could do is use this new API from FPTS with this pipeable do syntax. So we say here's our do, and it's a way of defining these procedural steps that need to take place in order. So the first thing we're going to do is bind this email. This is just what we're calling it. This could be called whatever we want. This could say like email validation. It doesn't matter. What you see down here, that's changed now because it doesn't exist. But anyhow, so what we do is we use the same thing that we described above, validate input field. And then next after that, we're going to do the same thing, but now on password. And this, if this fails, it's going to short circuit, drop, move straight past this one and drop into our error track. And it's going to log those errors. So what's interesting here is that we're using validate input field, which has this applicative implementation where there's parallel operations happening. And we've nested that inside of this do form validation where we're saying it's okay to run all of those at once on a single field, but we don't want to accumulate the errors from all of the fields all at once. We want to run them one at a time. Again, I'm just using input fields here to demonstrate this, but think how I was saying about an entire form section needs to be validated before the next form section gets validated. So what happens here is that same thing as above. This is pretty much exactly the same. And if we go ahead and, well, I actually need to change it down here. So instead of handle form validation, we called it do form validation. So we'll save that, come over here. Before I refresh, just another brief note or it's worth mentioning again. Here it's doing both of them at the same time. But whenever I refresh, if I click submit now, we only see email cannot be empty. So if we come in here and we do our thing, now we're good. Okay, what's wrong? At least one capital letter and at least one number. So we didn't add that. Now we did. Cool, and now it's finally moved on to the password. The password cannot be empty. Same thing applies. At least one capital letter. Cool, and we're good, and you can see validated email and password. Okay, so that's going to be it for this video. In the next video, we're going to talk about task either and how we can use that to create better abstractions around promises and make a network requests so that they're more composable. Because right now, if you're just using promise with a chain, that's okay. But whenever you need to compose that with multiple things, it can get really hairy whenever you end up in this pyramid of doom of different chain methods and you keep like indenting into your code to get to that solution. It can be hard to track where things are going wrong. And then on the flip side of that, they have try catch. But try catch can get really ugly too with a lot of await statements, and things become hard to track whenever you have try catch blocks nested in each other. So we're going to use task either to build a very declarative pipeline of how to orchestrate different network requests while gaining maximum composability. All right, so that's going to be it, and I'll see you guys then.